Tonight, we don't travel to the familiar places, not to Mars with its ancient red deserts, not to Saturn with its magnificent rings, not even to Jupiter with its endless storms. Tonight, we go much further than that, beyond Neptune, beyond the last known planet, into a region of the solar system so distant, so cold and so forgotten that sunlight itself barely reaches it. Out here, the sun is nothing more than a bright star, smaller than what you see on a clear night from your backyard. And yet, life exists out here, not biological life, but worlds, ancient, frozen, silent worlds that have been drifting through this darkness since before Earth had oceans. One of these worlds is Pluto, and around Pluto, 5 moons orbit in a dance so chaotic, so mathematically strange, that scientists are still trying to understand it. Tonight, we focus on one of those 5 moons, the smallest, the strangest, the most overlooked. Its name is Nyx, named after the ancient Greek goddess of night and darkness. And somehow, that name is perfect. Before we begin tonight's journey, if you found yourself here, you're exactly where you need to be. Theories Before Sleep was built for minds that can't stop wondering, for people who fall asleep better when their thoughts are somewhere vast, somewhere ancient, somewhere beautifully unknown. Every night, we release a new theory, a new mystery. Subscribe to Theories Before Sleep and turn on notifications so every night, without fail, a new journey is waiting for you on your pillow. Now, get comfortable. Close your eyes if you'd like. Tonight, we go to the edge of everything. This is Nyx. Nyx is not a quiet moon, not in the way we expect moons to be. When most people think about moons, they imagine something stable, something predictable, a body that orbits its planet and slowly turns, eventually locking into a single orientation. But Nyx is different. It belongs to one of the strangest systems in the solar system, orbiting the distant dwarf planet Pluto, far beyond Neptune, in a region where sunlight is faint and the rules begin to change. And its story begins not with ancient history, but with a discovery. In 2005, astronomers using the Hubble Space Telescope were studying Pluto in greater detail than ever before. At the time, Pluto was already known to have one large companion, Charon, a moon so massive that the two bodies orbit a shared center of gravity, creating what is often described as a binary system. But researchers suspected there might be more. Better instruments, sharper imaging, longer observation times. All of this allowed them to look deeper into the faint light surrounding Pluto. And then something appeared. Not bright, not obvious, just a faint point of light, barely distinguishable from the background. Then another. After careful analysis, those faint signals were confirmed as 2 new moons. One of them would be named Nyx. The name comes from Greek mythology, Nyx, the goddess of the night. A fitting name because Nyx exists in darkness, not just metaphorically, but physically. At Pluto's distance, sunlight is more than 1,000 times weaker than it is on Earth. Objects there do not shine. They reflect just enough light to be seen if you know where to look. And for a long time, no one knew exactly where to look. That is one reason Nyx remained hidden for so long. Despite being part of our solar system, despite orbiting a body we had known about since 1930, Nyx was invisible to earlier observations. Its size is small, roughly 50 kilometers across at its longest dimension. Its shape is irregular. Its surface reflects light unevenly. All of this makes it difficult to detect from a distance. especially when it is orbiting near a brighter object like Pluto. Earlier telescopes simply did not have the resolution or sensitivity to separate Nix from the background noise of space. It wasn't that it wasn't there. It was just lost in the darkness. The discovery changed that. Suddenly, Pluto was no longer a simple system. It became something more complex, more dynamic, more interesting, because Nix was not alone. It was part of a growing family of small moons, all orbiting the Pluto-Charon system in a delicate gravitational balance. This system is unique. Unlike most planets and their moons, Pluto and Charon are so similar in size that they orbit each other. This creates a shifting gravitational environment, one that affects everything around it. Nix moves through that environment. Its orbit is not random, but it is influenced by both Pluto and Charon. It follows a path that keeps it in resonance with the system, a kind of synchronized motion that prevents collisions and maintains stability. Even so, the environment is complex. For a small moon like Nix, that complexity matters. It shapes how it moves, how it rotates, how it behaves over time. In terms of physical characteristics, Nix is not a smooth world. It is not spherical. Like many small bodies, it lacks the gravity needed to pull itself into a rounded shape. Instead, it appears elongated, uneven, marked by impact craters and variations in terrain. Images taken later by the New Horizons spacecraft in 2015 revealed more detail. Nix's surface is relatively bright compared to many small bodies in the outer solar system. This suggests the presence of ice, possibly water ice, covering much of its exterior. That brightness is another contrast, because while its name is tied to darkness, its surface reflects more light than expected. This tells us something about its composition and its history. It may have formed from debris, fragments created during a massive collision early in the history of the Pluto system. That same collision is believed to have created Charon. If that is true, then Nix is not just a moon. It is a remnant, a piece of a much larger event, a fragment that never came together into something bigger. Instead, it remains small, irregular, orbiting at a distance. When scientists first confirmed its existence, the reaction was immediate. Not shock in the dramatic sense, but realization. The realization that Pluto was more complex than we thought. That even in the outermost regions of the solar system, systems could form with multiple bodies interacting in ways that were not immediately obvious. Nix became part of that realization. It represented a shift from seeing Pluto as a lonely object to understanding it as the center of a dynamic system. Comparing Nix to other small moons helps place it in context. Many small moons exist throughout the solar system, around Jupiter, Saturn, Uranus, and Neptune. Most of them share certain characteristics. They are irregular in shape. They are heavily cratered. They are remnants of formation processes or captured objects. In that sense, Nix is not unique, but the system it belongs to is. The Pluto-Charon system is one of the few places where such a small central body hosts multiple moons in stable orbits, all influenced by a binary gravitational center. This creates conditions that are different from those around larger planets, more delicate, more complex, more chaotic. Nix is part of that. It is not just orbiting Pluto. It is moving through a gravitational dance shaped by two bodies, and that affects everything. Its motion, its rotation, its long-term behavior. The fact that it remained hidden until 2005 also tells us something important. There are still things we have not seen, even in our own solar system, even around objects we have studied for decades. Detection depends on technology, on perspective, on knowing where to look. Before the Hubble observations, Nix was effectively invisible. After them, it became a known world. That transition from unknown to known is at the heart of exploration. And it continues, because even now we do not fully understand Nix. We know its size, its shape, its orbit, but there are deeper questions about its internal structure, about how it formed, about how it behaves over long periods of time. And those questions lead to something else. Because Nix is not just another small moon. It is a gateway, a way to understand the system it belongs to, a way to explore how small bodies interact in complex gravitational environments, a way to see how order can exist within apparent chaos. It began as a faint point of light, barely visible, almost missed, and now it is part of a story about motion, about instability, about a moon that does not follow the rules we expect. And this is only the beginning, because understanding what Nix is just the first step. Understanding what it does is where the real mystery begins. Pluto is not alone. For a long time, it was easy to imagine it that way, a distant, isolated world drifting at the edge of the solar system, cold, quiet, untouched. But that picture was incomplete. What surrounds Pluto is not emptiness, it is a system, a complex, tightly connected family of worlds moving together in ways that challenge everything we expect from moons and planets. At the center of this system is something unusual, not a dominant planet with small satellites, but a partnership. Pluto and Charon orbit each other. Charon is not a minor companion. It is large, about half the size of Pluto itself. This means the center of gravity between them does not lie inside Pluto, as it does for most planet-moon systems. Instead, it exists in space between them. Both bodies move around that point, together, locked in motion. If you were standing on Pluto, Charon would not drift slowly across the sky. It would hang there, massive, dominant, always in the same position, filling a large portion of the horizon, a constant. And if you were on Charon, Pluto would do the same. This is not a typical system. It is closer to a binary pair than a planet and its moon. And around this pair, something even more unusual exists. 4 smaller moons, Nix, Hydra, Kerberos, Styx. They are small, irregular, but their behavior is anything but simple. Each one orbits the Pluto-Charon pair, not just Pluto alone. This means their motion is influenced by 2 major gravitational sources, 2 centers of pull, 2 forces constantly shaping their paths. In most planetary systems, moons orbit a single dominant body. Their motion is relatively stable, predictable, governed by a clear central mass. Here, that simplicity does not exist. The presence of Charon changes everything. The gravitational environment becomes more complex, more dynamic, more unpredictable, and yet the system remains stable. At first glance, the orbits of these moons seem orderly. They follow paths that avoid crossing, maintaining distances that prevent collisions. But beneath that order lies something deeper, a pattern of resonance. Each moon is locked into a timing relationship with Charon's orbit. Styx completes its orbit in a ratio that matches Charon's motion. Nix follows a different ratio. Kerberos and Hydra follow others. These are not random. They are synchronized, like gears in a system, each moving at a rate that keeps everything aligned. This resonance helps maintain stability. Without it, the gravitational interactions could destabilize the system over time. Moons might drift, orbits might cross, collisions could occur. But the resonance prevents that. It creates structure, order within complexity. And yet, even with this structure, the system behaves in ways that are difficult to predict. Because while the orbits are stable, the rotations are not. This is where things become truly unusual. In most cases, moons become tidally locked. They rotate at the same rate they orbit, always showing the same face to their parent body. Charon does this with Pluto. Pluto does this with Charon. But the smaller moons do not. Nix, Hydra, Kerberos, and Styx do not settle into stable rotations. Instead, they tumble. Their orientations change over time. They spin in ways that are not synchronized with their orbits. This is rare, and it is a direct result of the system they exist in. The combined gravitational influence of Pluto and Charon creates a varying torque, a changing force that prevents the smaller moons from locking into a stable rotational state. As they move through their orbits, the gravitational pull shifts. The forces acting on them are not constant, and so their rotations remain chaotic. This makes the Pluto system one of the few places in the solar system where such behavior is clearly observed. A system where orbits are stable, but rotations are not. This duality, order in motion, chaos in spin, is what makes it unique. It defies the simple rules we often use to describe planetary systems. It shows that stability does not always mean uniformity, that systems can be balanced even when individual components behave unpredictably. This complexity also tells us something about the system's origin. The leading theory suggests that Pluto's moons formed from a massive collision. Early in its history, Pluto may have been struck by another large object. The impact would have ejected material into orbit. Over time, that material coalesced. Charon formed from the largest fragments. The smaller moons formed from the remaining debris. If this is true, then the entire system shares a common origin, a single event that created multiple bodies, each with its own path, each shaped by the same initial conditions, but evolving differently over time. This explains the alignment of their orbits, their relatively circular paths, their shared plane of motion. But it also explains their differences, because the smaller moons, formed from less material, never reached the size needed to stabilize their rotations. They remained irregular, sensitive to external forces, and so they continue to tumble. This brings us to a broader perspective. The Pluto system is part of the Kuiper belt, a vast region beyond Neptune filled with icy bodies, remnants of the early solar system. This region is not empty. It is populated by objects of various sizes, many of which may have experienced similar collisions. If Pluto's system formed through such an event, it suggests that similar systems could exist elsewhere in the Kuiper belt. Other binary pairs, other sets of small moons, other examples of complex gravitational interactions. In this sense, Pluto is not an anomaly. It is a representative, a window into how objects behave in the outer solar system, where conditions are different, where formation processes may follow different paths, where systems can evolve in ways that challenge our expectations. The study of Pluto's moons, including Nix, helps us understand that environment. It shows us how small bodies can interact in a multi-body system, how resonance can create stability, how gravitational complexity can lead to rotational chaos, and how all of this can persist over billions of years. Because that is perhaps the most remarkable part. This system is not new. It has existed for a very long time. Despite its complexity, despite its unusual behavior, it has remained intact, balanced, enduring, which means that the forces at work are not random. They are consistent, predictable at a deeper level, even if the surface behavior appears chaotic. Nix is part of that, one piece of a larger structure, a moon that does not follow simple rules, but still fits into a system that holds together. And understanding that system is essential. because it shows us that the solar system is more diverse than we once believed, that not all moons behave the same way, that not all systems follow the same patterns, and that sometimes the most distant places are the ones that reveal the most unexpected truths. Nix does not rotate the way a moon is supposed to. It does not settle into a rhythm. It does not repeat a pattern. It does not calm down over time. Instead, it tumbles endlessly. When we first discovered Nix, there was no reason to suspect anything unusual about its rotation. Like most small moons, it was expected to spin irregularly at first, then gradually slow down, and eventually become tidally locked, always showing the same face to its parent body. That is what gravity usually does. It removes chaos, it replaces it with order. But Nix never followed that path. The first real hint came decades after its discovery, when New Horizons reached the Pluto system in 2015. For the first time, we had detailed images, precise measurements, data collected from a close encounter rather than distant observation. And what that data revealed was unexpected. Nix was spinning, fast, irregularly, and more importantly, unpredictably. Its rotation was not just fast, it was chaotic. There was no single axis of rotation that remained fixed, no stable orientation, no repeating cycle. Instead, the moon was tumbling through space, constantly changing the way it spun. Imagine holding a rock in your hand and tossing it into the air. It spins, but the spin is not smooth. It flips, it twists, it rotates in multiple directions at once. Now imagine that motion, never stopping. That is Nix. Most moons do not behave this way. Over time, tidal forces act like a brake. They slow rotation, reduce irregular motion, and eventually lock the moon into a stable state. But Nix has not reached that state. And the reason lies in the environment it exists in. Because Nix does not orbit a simple system. It orbits two bodies. At the center of its motion is the gravitational relationship between Pluto and Charon. These two are not like a typical planet and moon. They are closer to equals. They orbit each other around a shared center of mass, which lies outside Pluto itself. This creates a moving gravitational field, a shifting center of influence. For Nix, this means the pull it feels is not constant. It changes as Pluto and Charon move. The direction of the force shifts. The strength of the force varies, and this has a direct effect on rotation. In a simple system, a moon can align itself, find a stable orientation, settle into a predictable spin. In a complex system like this, that alignment is constantly disrupted. Every time Nix begins to stabilize, the gravitational forces change. The system moves, the balance shifts, and the process starts again. This is where the concept of the three-body problem becomes important. In physics, the three-body problem describes how three objects interacting gravitationally create motion that is extremely difficult to predict. Unlike two-body systems, which have stable, repeating solutions, three-body systems can behave chaotically. Small differences in position can lead to completely different outcomes over time. Nix exists within such a system. Pluto, Charon, Nix, three bodies interacting. And while the orbit of Nix is stabilized through resonance, its rotation is not protected in the same way. There is no mechanism forcing it into a stable spin, no consistent torque guiding it toward equilibrium. Instead, the forces acting on it vary in both direction and magnitude. This leads to a condition where the rotation becomes chaotic, not random, but sensitive to initial conditions, sensitive to changes in the system, sensitive to the constant movement of Pluto and Charon. Once this chaotic rotation begins, it can persist. Because there is no simple path back to stability. The system does not provide the conditions needed to dampen the motion. Instead, it sustains it, feeds it, maintains it. This is what makes Nix so unusual. It is not the only object that can tumble. Some asteroids in the solar system exhibit non-principal axis rotation, what is often called tumbling. But these are usually smaller bodies, objects not strongly influenced by a nearby massive system, and even then, many eventually settle into more stable states. Nix is different. It is part of a structured system, a system with resonance and order in its orbits, and yet it remains rotationally chaotic. There are very few known moons that behave like this, and none in a system quite like Pluto's. This makes Nix a rare example, a natural laboratory for studying how chaotic rotation can persist, and what conditions are required to maintain it. But beyond the physics, there is something else, something more visual, because if you could stand on the surface of Nix, the experience would be unlike anything else in the solar system. There would be no stable horizon, no consistent direction, no predictable sky. Pluto would not rise and set in a regular pattern. Charon would not follow a fixed path. Instead, the sky would move unpredictably. Objects would appear, disappear, shift positions in ways that would feel disorienting. The ground beneath you would not change, but your sense of direction would. Day and night would not follow a simple cycle. Light would come and go irregularly, depending on how the moon was oriented relative to the sun and the Pluto-Charon system. Shadows would stretch in unexpected directions, then change, then shift again. There would be no rhythm to rely on, no pattern to follow, only motion, constant, unpredictable, unending. This is the reality of a world that cannot stabilize, a world where the forces acting on it are too complex to allow calm. And yet, it continues, orbit after orbit, year after year, maintaining this chaotic rotation over immense spans of time. Which raises another question. Will it ever stop? Will Nix eventually settle? The answer is uncertain. If the system remains as it is, the chaotic rotation could continue indefinitely. There is no clear mechanism to remove the energy from the system in a way that leads to stable locking. Unless something changes, an external force, a collision, a shift in orbital dynamics, Nix may remain in this state for billions of years, a moon that never finds equilibrium, a body that exists in a constant state of motion. This challenges our understanding of how moons evolve. It shows that tidal locking is not inevitable in all systems, that under certain conditions, chaos can persist, not as a temporary phase, but as a long-term state. And that is what makes Nix so important, because it reveals something fundamental. That stability in orbit does not guarantee stability in rotation. That order and chaos can exist together. That a system can be balanced, while still containing elements that never settle. Nix is one of those elements. A small moon, barely visible from a distance, but behaving in a way that forces us to rethink what we expect from worlds like it. And in that motion, in that endless tumbling, it tells a story, not of calm, but of complexity, not of order alone, but of a balance that includes chaos. A reminder that even in the quietest parts of the solar system, there are places where nothing ever truly stands still. Nix was supposed to be simple, a small moon, cold, grey, unremarkable. That is what scientists expected when they first studied Nix from a distance. In the outer solar system, many small bodies appear neutral in color, muted tones shaped by ice, rock, and long exposure to space. But when New Horizons finally sent back detailed images in 2015, that expectation changed. Because Nix was not grey. It had colour, subtle at first glance, but undeniable when measured carefully. A faint reddish tint across parts of its surface. And that raised a question that turned out to be more complicated than it seemed. Why would a small, irregular moon so far from the sun show colour at all? Colour in space is not random. It is a signature, a clue to composition, to chemistry, to history. And in the outer solar system, colour becomes even more important because the processes that create it are slow, subtle, and often hidden. To understand Nix, we have to understand where that red comes from. One of the leading explanations involves a class of substances known as tholins. Tholins are not a single material, but a mixture of complex organic molecules. They form when simple compounds like methane, nitrogen, or carbon monoxide are exposed to radiation, ultraviolet light from the sun, charged particles from space, cosmic radiation traveling through the solar system. When these forms of energy interact with simple molecules, they break them apart and recombine them into more complex structures. Over time, this process creates substances that are dark, reddish, and rich in carbon. These materials are common in the outer solar system. They have been detected on distant objects, including Pluto itself, and many bodies in the Kuiper belt. And they are important because they represent a kind of chemical evolution. Not life, but the building blocks of more complex chemistry. On Nix, tholins are a strong candidate for explaining the reddish tint. But that raises another question. How did they get there? Because Nix is small, it does not have an atmosphere. It cannot easily retain volatile gases like methane, which are often involved in the formation of tholins. So if tholins are present, they likely did not form entirely in place. They may have been delivered, and this is where the connection to Charon becomes important. Charon has one of the most striking features in the Pluto system, a dark red region at its north pole. This region is believed to form through a specific process. Methane gas escapes from Pluto's atmosphere and travels through space. Some of it reaches Charon, where it freezes onto the surface in colder regions. Over time, radiation transforms that frozen methane into tholins. The result is a reddish cap, a region that stands out against the otherwise neutral surface. Now imagine that material not staying in one place. Impacts, micrometeoroid collisions, and other processes can eject particles into space. Tiny grains of material moving through the Pluto system. Some of those particles could reach Nix. Slowly, over time, they could accumulate, creating a thin layer of reddish material on its surface. This is one possible explanation. That Nix's color is not entirely its own. That it is, at least in part, a result of exchange within the Pluto system. Material moving from one body to another. A shared chemistry, a shared history. But there may be more. Because radiation does not just affect materials that arrive from elsewhere. It also alters what is already there. Even if Nix started with a relatively neutral composition, ice mixed with rock, billions of years of exposure to radiation could change that. Breaking molecules, rearranging structures, creating new compounds, darkening and reddening the surface over time. This means that the color we see today is not necessarily the original state. It is the result of transformation. A long process, slow but relentless. This is why color in the outer solar system is so significant, because it is not just about appearance, it is about history. It tells us what materials are present, what processes have acted on them, and how those processes have changed over time. When we compare Nix to other bodies, this becomes clearer. Many objects in the Kuiper belt show reddish hues. Some are deeply red, almost dark brown. Others show lighter tones, with patches of color across their surfaces. These variations reflect differences in composition, in radiation exposure, and in age. For example, Pluto itself shows a wide range of colors: bright white ice, dark regions, and reddish areas rich in tholins. Charon shows a more limited range, but with that distinctive red polar cap. Other distant objects, like some trans-Neptunian objects, display even stronger red coloration. Nix fits into this pattern, but in a subtle way. Its color is not extreme. It is not one of the reddest objects we know, but it is enough to tell us that similar processes are at work, that even a small moon with limited gravity and no atmosphere can develop a chemically altered surface, and that surface can preserve information. There is also the question of distribution. Is the red color uniform across Nix, or is it concentrated in certain regions? The data we have suggests variation. Some areas appear more reflective. Others show stronger color. This could indicate differences in composition or differences in exposure. Perhaps some regions have been more recently resurfaced by impacts, exposing fresher, less altered material, while others have remained undisturbed for longer, allowing tholins to accumulate. These differences matter because they provide clues about the processes shaping the moon and about the balance between renewal and alteration. Too much resurfacing and the color would be erased. Too little and the entire surface would become uniformly dark. Nix appears to sit somewhere in between, a surface that has been altered but not completely homogenized, a record that still contains variation and therefore information. What makes this even more interesting is the scale. Nix is small, only tens of kilometers across, and yet it shows evidence of complex chemistry. This tells us that size is not the limiting factor, that even small bodies can host processes that create and preserve chemical signatures, that the outer solar system is not just a collection of inert objects, but a dynamic environment where even the smallest worlds are shaped by interactions between radiation, material, and time. There is still much we do not know. The exact composition of Nix's surface has not been measured in detail. We do not know the precise thickness of the reddish layer. We do not know how deep these materials extend, or how they vary across the moon. And without new missions, these questions may remain unanswered. But even with limited data, the presence of color changes how we see Nix. It is no longer just a dark, tumbling object. It is a chemically active surface, a place where molecules have been transformed, where material has been exchanged, where history is written not just in shape and motion, but in color. And that color is subtle, easy to overlook, but once seen, impossible to ignore, because it tells us that even in the coldest, darkest parts of the solar system, change is always happening. The journey to Nix did not begin with a discovery. It began with a launch. In January 2006, a spacecraft left Earth with a destination unlike any mission before it. Not Mars, not Jupiter, not Saturn, but the distant edge of the solar system. Its name was New Horizon, its target Pluto, and everything orbiting it. The mission would take nearly a decade, 9 years of travel through deep space, passing Jupiter for a gravity assist, gaining speed, then continuing outward into colder and darker regions where sunlight becomes little more than a faint glow. For most of that journey, there was nothing to see, no close encounters, no detailed observations, only distance and anticipation. Because at the end of that path, was a system we had never truly seen. By the time New Horizons approached Pluto in July 2015, expectations had been built over years of indirect observation. Scientists had models, estimates, predictions about what the system would look like. They knew about Charon, and they knew about the smaller moons, Nix among them. But those moons were still just points of light, unresolved, unclear. From Earth, even with the best telescopes, Nix was nothing more than a faint signal. So the expectations were cautious. A small, irregular object, probably grey, probably heavily cratered, probably simple. That was the assumption. And then New Horizons arrived. The flyby itself was fast, very fast. The spacecraft was moving at over 14 kilometers per second relative to Pluto. It would not slow down. It would not enter orbit. It had one chance, one pass. Everything had to be captured in a narrow window of time. For Nix, that window was even smaller. While Pluto and Charon received the majority of attention, the smaller moons were secondary targets, observed as the spacecraft's instruments swept across the system. And yet, even in that limited time, something unexpected appeared. When the first high-resolution images came back, Nix was no longer a point of light. It was a world. Small, yes, but detailed. And immediately, it was clear that it did not match expectations. Nix was not spherical. It was elongated. An oval-like shape stretched along one axis, giving it a slightly flattened appearance. This was consistent with a body that lacked the gravity needed to pull itself into a sphere. But seeing it clearly, seeing the actual form, was different from predicting it. The surface also revealed variation, not just craters but differences in brightness, subtle changes across its terrain. And then, something else, a region that stood out. A reddish area, not dominant, not covering the entire surface, but distinct enough to raise questions, because color in the outer solar system is never random. This red spot became one of the most intriguing features of Nix. It suggested chemical processes, surface variation, possibly the presence of complex organic materials, tholins, formed through radiation and chemical reactions. But more importantly, it showed that Nix was not uniform. It had history, it had complexity, it had variation. And all of this was revealed in a very short time. Because New Horizons did not linger, it could not. The spacecraft had only a limited period, roughly 9 hours of optimal observation during closest approach, to gather its most detailed data. 9 hours, after 9 years of travel. In that time, it captured images, measured light, recorded data that would take months, even years, to fully transmit back to Earth due to the vast distance. Every second mattered, every frame, every measurement. For Nix, those hours defined everything we know today. The images were not continuous, they were snapshots, moments captured as the spacecraft passed through the system. Angles changed quickly, distances shifted rapidly, lighting conditions varied, and yet from those fragments, a picture emerged. A small, bright, elongated moon, with a surface that reflected more light than expected, with subtle coloration, with a shape that confirmed its irregular nature, and with rotation that hinted at something far more complex. Because even in those limited observations, there were signs that Nix was not behaving like a typical moon. Its orientation changed between images. Its surface did not appear in a consistent alignment. At first, this might seem like a minor detail, but it was a clue that would later connect to the discovery of its chaotic tumbling, a rotation that does not stabilize, a motion that does not repeat. All of that began with those brief observations. And then, just as quickly as it arrived, New Horizons left. The spacecraft continued onward, deeper into the Kuiper belt, leaving Pluto and its moons behind. No second pass, no return. The data collected during those hours became the foundation of everything we know. And everything we don't, because while the flyby revealed much, it also highlighted limitation. We saw Nix, but not completely. We observed it, but only from certain angles. We measured it, but only within the constraints of a fast-moving encounter. There are still details we do not have. Full surface maps, precise internal structure, long-term observations of rotation and variation. All of that remains out of reach, for now, and perhaps for a long time. Because missions to Pluto are rare, the distance alone makes them difficult, expensive, time-consuming. New Horizons took nearly a decade to arrive. Any future mission would require similar commitment, and there are no guarantees, no confirmed plans to return to Pluto's system in the near future, which means that those 9 hours may remain the only close look at Nix for generations. This gives those observations a kind of weight, a significance beyond the data itself, because they represent a moment, a single opportunity, a brief encounter between humanity and a distant world, a world that had been invisible for most of our history, and that may remain distant for much of our future. There is something almost poetic about that. A moon discovered in 2005, seen clearly for the first time in 2015, and then left behind, still orbiting, still tumbling, still moving through a system we barely understand, while we remain here, studying image, interpreting data, trying to piece together a story from a handful of moments. New Horizons did not just show us what Nix looks like, it showed us how much we still don't know, and how rare true exploration really is. Because sometimes, after years of travel, after all the preparation, after all the waiting, you get only a few hours. And from those hours, you have to understand an entire world. Nix did not form gently. It was not slowly assembled from calm, drifting material. It was not captured from elsewhere and placed into orbit. Its origin is far more violent. To understand where Nix came from, we have to go back to a time when the outer solar system was not quiet, a time when collisions were common, when objects were still forming, when stability had not yet taken hold. Billions of years ago, in the distant region where Pluto exists today, the environment was crowded, not with planets as we know them, but with building blocks, icy bodies, rocky fragments, objects ranging in size from small debris to large protoplanets. These bodies move through space on intersecting paths, and eventually, some of them collided. One of those collisions may have created everything we see in the Pluto system today. The giant impact theory proposes that Pluto was struck by another large object, possibly comparable in size to Pluto itself. Not a small impact, not a surface event, but a collision on a planetary scale. When that impact occurred, the energy released would have been immense, enough to melt large portions of both bodies, enough to eject vast amounts of material into space, enough to reshape the entire system. The collision would not have destroyed Pluto completely. Instead, it would have altered it, changed its structure, and most importantly, created debris. That debris did not disappear. It spread outward, forming a disk around Pluto. A cloud of fragments, ice, rock, and mixed material, moving in orbit. Over time, that material began to interact. Pieces collided with each other, merged, separated. Gradually, through a process known as accretion, larger bodies began to form. The largest of those bodies became Charon. Charon is too large to be explained by simple capture. Its size, its composition, and its orbit all suggest that it formed from the same event that created the debris disk. It is not just a moon, It is a partner, a result of the same collision that shaped Pluto itself. But not all of the debris formed a single large body. Some of it remained in orbit, smaller fragments, less massive clusters, and from those, the other moons formed. Nix, Hydra, Kerberos, Styx, each one a remnant, each one a piece of that original event. This explains several things at once. It explains why the moons share similar orbital planes. They formed from the same disk, so their motion is aligned. It explains why their orbits are relatively circular. They evolved within a structured environment, gradually stabilizing over time. And it explains why they are irregular, because they did not accumulate enough mass to become spherical. They remained small, fragmented, incomplete. In the case of Nix, this origin is reflected in its shape. Elongated, uneven, a body that never had the gravity needed to smooth itself out. But the giant impact theory goes deeper than just explaining shape and orbit. It also explains composition. If Nix formed from debris, then its material should be related to that of Pluto and Charon. Not identical, because different layers of the original bodies may have been involved, but similar enough to suggest a shared origin. Observations from New Horizons support this idea. Nix appears to have a surface rich in water ice, brighter than many other objects in the outer solar system. This suggests that the material it formed from included significant amounts of ice, likely originating from the outer layers of the colliding bodies. The collision itself would have sorted material. Heavier, denser components may have remained closer to Pluto. Lighter, icy material could have been ejected farther out. This creates variation. Charon, being large, may contain a mix of materials from different layers. Nix and the other small moons may represent specific portions of that debris, perhaps more ice-rich, perhaps more fragmented. This is why studying Nix is important, because it is not just a moon, it is a sample, a preserved fragment of a massive event, a piece of history. The giant impact theory also explains the dynamics of the system. After the collision, the newly formed bodies did not immediately settle into stable orbits. There would have been chaos, interactions, gravitational shifts. Over time, those interactions led to the current configuration. Resonances formed, orbits stabilized, but not everything became simple. The complexity of the system, the presence of a binary pair, the multiple small moons, the chaotic rotation of Nix, can all be traced back to that initial event. It created a system that is balanced, but not simple. There are still questions. How large was the impactor? What was its composition? How fast did it collide with Pluto? Different models produce different outcomes. Some suggest a slow, grazing collision. Others suggest a more direct, high-energy impact. Each scenario changes the details, but the overall picture remains consistent. A massive collision, a debris disk, the formation of multiple moons. One of the most interesting aspects of this theory is how it connects Pluto to other bodies in the solar system, because this is not the only place where a giant impact may have occurred. The Earth-Moon system is also believed to have formed through a similar process, a collision between the early Earth and a Mars-sized object. That event created the Moon. In both cases, we see a pattern, large bodies forming smaller companions through catastrophic events, material being redistributed, systems emerging from destruction. This suggests that giant impacts are not rare. They are part of planetary evolution, especially in the early solar system, when objects were still forming and collisions were more frequent. Nix is part of that pattern, but it is also unique because of where it is, because of the system it belongs to, because of the way it behaves. It is not just a fragment. It is a fragment that exists in a complex gravitational environment. a fragment that never fully stabilized, a fragment that continues to reflect the chaos of its origin. There is also the possibility that not all of Pluto's moons formed at the same time. Some models suggest that after the initial collision and formation of Charon, additional impacts or interactions could have contributed to the creation of the smaller moons. This would make the system even more complex, a layered history, multiple events contributing to the final structure. But even in those scenarios, the giant impact remains central. It is the starting point, the event that made everything else possible. Without it, there would be no debris disk, no Charon, no Nix, no system as we see it today. What remains remarkable is how stable the system has been. Despite its violent origin, despite its complexity, it has endured for billions of years, maintaining its structure, maintaining its orbits, even maintaining the chaotic rotation of Nix. This tells us something important, that even systems born from destruction can find balance, not perfect balance, not simple balance, but a form of stability that allows them to persist. Nix is part of that stability, even in its chaos, even in its tumbling. It remains in orbit. It remains part of the system, a small piece of a much larger story, a story that began with a collision, a moment of extreme energy, a transformation that reshaped an entire region of space. And from that moment, from that violence, came a set of worlds, each one carrying a piece of that history, each one telling part of the story. Nix is one of those pieces, not the largest, not the most obvious, but one of the clearest reminders that even in the quietest parts of the solar system, everything began with something far more violent than we can easily imagine. Nix did not form alone. From the very beginning, its story has been tied to another small, distant world, Hydra. They are not identical. They do not share the same exact orbit. They do not look the same. And yet, they belong together. When scientists studied the Pluto system after the arrival of New Horizons, one pattern became impossible to ignore. Nix and Hydra were not just two random moons. They were part of a structure, a system that hinted at a shared origin. Both orbit far beyond Pluto and Charon, moving in stable paths that are not accidental. Their orbits are synchronized through resonance, precise timing relationships with Charon's motion. Hydra takes longer to orbit than Nix. Nix takes longer than the inner moons. But the ratios between these orbits form a pattern that suggests they were not captured independently. They formed together, from the same event, from the same material, after the same moment of destruction. This is one of the strongest pieces of evidence supporting the giant impact theory. Because when moons form from a debris disk, they inherit certain characteristics: aligned orbits, similar compositions, resonant motion, and that is exactly what we see. Nix and Hydra are not just neighbors, they are siblings, fragments of a single origin. But to understand that origin, we have to imagine something far more dramatic than anything we see today. We have to go back billions of years, to a time when the outer solar system was still forming, when objects moved through space on unstable paths, when collisions were not rare but inevitable. Somewhere in that early environment, Pluto encountered another massive body, not a small impactor, not a minor collision, but something large enough to change everything. The exact details are still uncertain, but the general picture is clear. Two bodies approached, gravity pulled them together, and then they collided. The moment of impact would have been instantaneous on a cosmic scale. A flash of energy, shockwaves traveling through both bodies, material melting, vaporizing, being thrown outward. The collision did not simply break the surface, it reshaped the entire system. Large portions of both objects were ejected into space, not lost, not scattered randomly, but placed into orbit. A ring of debris surrounding Pluto. That debris was not uniform. Some fragments were large. Some were small. Some were rich in ice. Others contained more rock. They moved, collided with each other, merged, separated. Over time, that chaotic cloud began to organize. The largest fragments gathered together, forming Charon. The smaller fragments remained, and from those, Nix and Hydra emerged. They formed together because they came from the same disk, the same region of debris. They did not arrive later. They were there from the beginning. This explains why their orbits are so closely related, why they move in harmony rather than conflict, why they fit into the system so precisely, because they were shaped by the same forces, at the same time, in the same environment. But the impact itself, what did it look like? We can only imagine. A collision in deep space. No atmosphere, no sound, but immense energy. Two icy worlds colliding at kilometers per second. The surfaces would have shattered. Material would have been launched outward in all directions. A glowing cloud of debris expanding, then falling back under gravity. Fragments colliding again and again, some escaping entirely, others settling into orbit. For a brief time, the region around Pluto would have been filled with motion, a storm of ice and rock. Then, slowly, order, the debris disk flattening, particles aligning, orbits stabilizing. From that chaos, a system formed, and within that system, Nix and Hydra took shape. There is strong evidence supporting this model. Not direct observation of the collision itself, but patterns that point to it. The alignment of the moon's orbits, the near circular paths they follow, the shared orbital plane. These are not features expected from captured objects. Captured moons often have irregular, tilted, or highly elliptical orbits. They reflect a chaotic origin, but Nix and Hydra do not. Their motion is organized, structured, consistent with formation from a disk. There is also the question of composition. Data suggests that these moons are rich in water ice, brighter than many other small bodies in the outer solar system. This indicates that they formed from material that was once part of larger bodies, material that had already differentiated or been processed, not primordial debris alone, but fragments of something bigger, something that had structure before it was broken apart. All of this supports the idea of a giant impact, a single event that explains multiple features at once. But beyond the specifics of Pluto, this tells us something larger, something about the early solar system itself. It was not a calm place. It was violent. Collisions were common. Objects were still forming, still moving, still interacting. And those interactions were not gentle. They were destructive, but also creative. Because from those collisions came new worlds, new systems, new structures. The formation of Earth's moon is believed to have followed a similar path. A Mars-sized body striking the early Earth, ejecting material into orbit, that material forming the moon. In both cases, we see the same pattern. A large impact, a debris disk, the formation of one or more moons. But there are differences. Earth's moon is large, spherical, geologically active in its early history. Nix and Hydra are small, irregular, cold, inactive. This reflects differences in scale, differences in material, differences in the energy of the collision. But the underlying process is the same. This suggests that giant impacts are a fundamental part of planetary evolution, not rare events, but expected ones, especially in the early stages of system formation. It also suggests that many of the objects we see today are not original. They are products of transformation, of destruction followed by reassembly. Nix is one of those products. a fragment that never became large enough to dominate, never gathered enough mass to become spherical, but still part of the system, still part of the story, still carrying information about the event that created it. And that is what makes it important. Because by studying Nix and Hydra together, we are not just looking at two small moons, we are looking at the result of a massive collision, a moment that reshaped an entire region of space, a moment that turned two bodies into many, a moment that left behind a system that still exists today. And even now, billions of years later, that history is still visible in their orbits, in their composition, in the way they move, and in the fact that they exist at all. Because without that collision, there would be no Nix, no Hydra, no system like this, only a single distant world. Instead, we have something far more complex, far more interesting. A reminder that even in the quietest parts of the solar system, everything began with violence. Standing on Nix would not feel like standing on a moon. It would feel like standing on something that never quite decides where down is. The surface of Nix is small, only a few dozen kilometers across. Its gravity is extremely weak. If you were able to stand there, your weight would almost disappear. A simple jump could send you drifting meters above the ground. A stronger push, and you might not come back down the way you expect, because even the ground beneath you is not what you're used to. It is not smooth, not stable in the familiar sense. It is uneven, irregular, shaped by impacts and time. Rocks are scattered, craters cut into the surface. The terrain shifts in angles rather than gentle curves. And yet, despite all of that, the strangest part would not be the ground. It would be the sky. From Nix, the sky is never still. Above you, dominating everything, would be Charon. Not small, not distant, but enormous. Charon would appear far larger than Earth's moon does from Earth. It would hang in the sky like a massive world, its surface visible in detail, craters, plains, subtle color differences, and nearby you would also see Pluto, smaller than Charon from this perspective, but still unmistakable. Two worlds in the sky, both moving, both shifting positions over time, but not in a simple, predictable way, because Nix is not stable. It tumbles, constantly. As it rotates, the orientation of the surface changes. The direction you are facing relative to space changes. The horizon itself seems to move, even though the ground beneath your feet remains fixed. This creates an experience unlike any other place in the solar system. There is no consistent east or west, no stable sense of direction. One moment, Charon might be above you. Then, slowly, or sometimes not so slowly, it would drift toward the edge of your view, then disappear. Not because it has set below a horizon in the usual sense, but because the ground you are standing on has rotated away from it. Moments later, Pluto might appear from another direction, or both might vanish, leaving only stars. And then, without warning, one of them returns. This is what tumbling does. It removes predictability. It replaces cycles with irregular motion. Even the concept of a day becomes meaningless. On Earth, we define a day by the rotation of the planet relative to the Sun. On Nix, that rotation is chaotic. There is no fixed period, no consistent pattern. Sunlight does not rise and set in a regular way. Instead, it appears, disappears, returns at unexpected angles. The Sun itself, already faint at Pluto's distance, would be just a bright star in the sky. Not a large disk, not a dominant presence, just a point of light, brighter than the others, but not overwhelming. And yet, even that light would behave strangely. Because as Nix tumbles, the angle at which sunlight reaches the surface constantly changes. Shadows stretch in different directions, then shift, then disappear entirely. A rock that casts a shadow in one direction might cast it in another just minutes later or hours. There is no rhythm, no repeating sequence, only change. If you stayed in one place long enough, you would begin to notice something else. The stars themselves would move in unusual ways. On Earth, stars rise and set in predictable arcs. On Nyx, their motion would be irregular. They would drift, twist, shift across the sky in patterns that do not repeat, because your frame of reference, the ground you are standing on, is not stable. It is rotating in a complex way, combining multiple motions at once. This would make navigation almost impossible without instruments. You could not rely on the sky to guide you. You could not use consistent landmarks. Everything changes constantly. There is also the silence. No atmosphere means no sound, no wind, no echo, no movement of air. Every step would be quiet, every motion contained. Even if you jumped, the only sensation would be your own movement. The environment would feel frozen, not just in temperature, but in behavior, except for the sky, which never stops. Temperature would be extreme. Far from the sun, the surface of Nyx is incredibly cold, colder than almost any place on Earth. Cold enough that water exists only as ice, cold enough that even some gases freeze solid. And because there is no atmosphere, there is nothing to retain heat. The side facing the sun warms slightly. The side in darkness becomes even colder. But with the tumbling motion, these conditions do not stay fixed. A region that was exposed to light may suddenly rotate into darkness. A shadowed area may become illuminated. This creates rapid transitions, not in seconds, but in unpredictable intervals. Another consequence of low gravity and tumbling is how objects would behave. If you drop something, it would fall, but slowly. If you threw something, it could travel far, but the direction it travels relative to the surface might not match your expectations. Because your orientation is changing, even simple actions would feel unfamiliar. Walking would require caution. A strong step could lift you too high. A misjudged movement could send you drifting. And with such low escape velocity, it would not take much to leave the surface entirely. This makes Nyx a place where balance is not just physical, but spatial. You are constantly adjusting, not just to the ground, but to the way the world is moving around you. And then there is the emotional experience, because beyond the physics, beyond the motion, there is something else: isolation. Nyx is small, distant, far beyond Neptune, far beyond the main regions of planetary activity. From its surface, you would see Pluto and Charon, but beyond them, darkness, a vast field of stars, brighter than we see from Earth, because there is no atmosphere to scatter light, but still distant, still unreachable. There are no other nearby worlds, no large bodies filling the sky, only the system you are part of, and everything else far away. This creates a sense of scale, a sense of being in a place that is not just physically distant, but separate, disconnected from the rest of the solar system. And in that environment, time feels different, not because it moves differently, but because there is no cycle to measure it, no sunrise to mark a beginning, no sunset to mark an end, only motion, only change, only the continuous tumbling of the moon beneath your feet. If you stayed long enough, you would stop trying to predict it, stop looking for patterns, stop expecting repetition. You would simply observe. Watch as Pluto appears and disappears, as Charon dominates the sky, then fades away, as light and shadow move without warning. And in that observation, you would understand something: that Nyx is not broken, It is not malfunctioning. It is simply existing under conditions that do not allow stability. It is a world shaped by complexity, a place where the usual rules do not apply. And standing there, in that constant motion, you would not feel like you are on a moon. You would feel like you are on something else entirely. A drifting surface, a moving perspective, a place where nothing in the sky ever stays the same. The cold on Nix is not something you would simply feel. It is something that defines everything. Out there, beyond the orbit of Neptune, sunlight has weakened to almost nothing. By the time it reaches Nix, it is no longer the dominant force it is near Earth. It is distant, faint, barely more than a bright point in the sky. And without a strong source of energy, temperature collapses. On the surface of Nix, temperatures can fall to around 30-50 Kelvin. That is only a few tens of degrees above absolute zero. At that level, heat is not just low, it is almost absent. Molecules barely move. Energy transfer is minimal. Everything slows down. If you could stand there, the cold would not feel like winter. It would feel like nothing. Because in a vacuum, without an atmosphere, there is no air to carry temperature to your skin. There is no wind, no chill in the way we understand it. Heat leaves you directly, radiating into space, silently, continuously, until there is nothing left to give. And that emptiness extends beyond temperature. Because Nix does not have a true atmosphere, there is no layer of gas surrounding it, no sky in the traditional sense, no clouds, no pressure. But that does not mean there is nothing at all. Around Nix, there may exist a faint, temporary envelope of particles. Not an atmosphere as we know it, but a trace, a thin presence of molecules that appear and disappear over time. These particles are not held by gravity in any stable way. Nix is too small for that. Instead, they come from the surface itself. When sunlight, weak as it is, reaches certain areas, it can provide just enough energy for frozen materials to sublimate, to transition directly from solid to gas. Molecules lift from the surface, drift briefly, and then escape into space, or fall back again. This creates something like a momentary atmosphere, a ghost of one, never stable, never thick, just a constant exchange between surface and space. Among these materials, nitrogen may play an important role. In the Pluto system, nitrogen is common. It exists as ice on Pluto's surface, forming vast frozen plains, and through interactions between Pluto and its moons, some of that material may reach Nix, deposited through impacts, transferred as particles moving through the system. Over time, this could create thin layers of nitrogen frost on Nix's surface. A coating, light in color, fragile, sensitive to even the smallest changes in temperature. In regions where sunlight reaches, that frost may sublimate. In shadowed regions, it may remain. But because Nix tumbles, those regions do not stay fixed. Areas that were once in darkness rotate into light. Areas that were warmed fall back into shadow. This creates a surface that is constantly changing at a microscopic level. Frost forming, frost disappearing, a slow, silent cycle, but one without rhythm. Because there is no stable day, no predictable exposure, only motion. And all of this happens in complete silence, absolute silence, not the quiet of a calm night on Earth, not the stillness of a remote desert, but the absence of sound itself. On Nix, there is no air, no medium to carry vibrations, no way for sound waves to travel. If you moved, you would hear nothing. If you struck the ground, there would be no echo. Even if something collided with the surface nearby, the event would produce no sound, only motion, only visual change. Silence on Nix is not something you notice. It is something that surrounds everything, a constant condition, unbroken, total. And in that silence, the sense of isolation becomes stronger. Because Nix is not just distant, it is among the most isolated places in the solar system, far beyond the major planets, far beyond regions where sunlight still dominates, far beyond places we regularly explore. From its surface, you would see Pluto and Charon, close enough to dominate the sky at times, but beyond them, nothing nearby. No large planets filling the horizon, no neighboring worlds within easy view, only stars, countless stars, sharp and clear against the blackness of space, but distant, unreachable. The nearest structures of the solar system, the Kuiper belt objects, are spread across vast distances, too far to appear as anything more than points of light. This creates a sense of separation that is difficult to describe, because on Earth, even in the most remote locations, there is still a connection to the environment. Air, sound, movement. On Nix, that connection is gone. There is only surface and space, and between them almost nothing. Even gravity contributes to this feeling. It is weak, so weak that standing still would feel unnatural. Every movement would need to be controlled, every step measured. You would not feel anchored to the ground. You would feel temporary, as if you are only lightly attached to the surface, as if a stronger motion could lift you away. And in a way, it could. This combination, extreme cold, near vacuum, weak gravity, constant tumbling, creates a place that is not just hostile, it is unfamiliar. A place where none of our instincts apply, where direction is uncertain, where time is difficult to measure, where the environment does not respond in ways we expect, and yet it is real. Nix exists like this, right now, tumbling through space, covered in frost that forms and disappears, surrounded by particles that never settle, moving in silence, orbiting in darkness. It is one of the strangest environments in the solar system, not because of a single extreme condition, but because of how all those conditions combine: cold that removes energy, vacuum that removes sound, motion that removes stability, distance that removes connection. Together, they create something rare, a world that feels almost detached from the rest of the solar system, a place where the usual rules are replaced by something quieter and far more alien. And standing there, if it were possible, you would not just feel the cold, you would feel the absence of warmth, of sound, of stability. A reminder that in the farthest reaches of our system, there are places that are not just different, but almost beyond experience itself. Nix does not exist in isolation. It orbits Pluto, and it belongs to a tightly bound family of moons shaped by a violent past. But beyond that local system, there is something far larger, an environment that defines what Nix is made of, where it came from, and why it looks the way it does. That environment is the Kuiper belt. To understand Nix, you have to understand this region, because Nix is not just a moon. It is a fragment of the Kuiper belt itself. The Kuiper belt begins just beyond the orbit of Neptune and stretches outward for billions of kilometers. It is not a narrow ring, but a vast three-dimensional region filled with objects, remnants of the early solar system that never came together to form a planet. Billions of them. Some are small, no larger than a few kilometers. Others are hundreds of kilometers across. A few, like Pluto, are large enough to be classified as dwarf planets. These bodies are made primarily of ice mixed with rock, water ice, methane, nitrogen, carbon monoxide. Materials that can survive in the cold, distant environment where sunlight is weak and temperatures remain near absolute zero. This region is ancient. It has changed far less than the inner solar system. Closer to the sun, planets formed, migrated, collided, and reshaped their surroundings. Much of the original material was either incorporated into planets or ejected from the system. But in the Kuiper belt, many of those early fragments remained, preserved, cold, relatively untouched. This is why the Kuiper belt is so important. It is not just a collection of distant objects, it is a record of what the solar system was like in its earliest stages. And Nix, in a very real sense, is part of that record. Although it formed within the Pluto system, likely from debris created by a giant impact, it still carries the chemical signature of the region it comes from. The materials that make up Nix were not created in isolation. They originated in the same environment as the Kuiper belt objects around it. Ice-rich, carbon-bearing, sensitive to radiation. This is why Nix shows features that connect it to the broader Kuiper belt. Its surface reflects light more strongly than many darker outer solar system bodies, suggesting the presence of relatively clean ice. At the same time, subtle coloration hints at the presence of more complex materials, products of long-term exposure to radiation. These characteristics are not unique to Nix. They are part of a pattern. Across the Kuiper belt, objects display a range of colors and reflectivities. Some are bright and icy, others are dark and reddish. Many fall somewhere in between. These differences tell us about composition, about how long surfaces have been exposed, about how radiation has altered materials over time. Nix fits into this spectrum, not at the extreme ends, but clearly within it. This suggests that despite being part of a specific system, it shares a common heritage with countless other objects in the Kuiper belt. That heritage goes back to the formation of the solar system. In its earliest phase, a disk of gas and dust surrounded the young sun. Within that disk, material began to clump together, forming planetesimals, small building blocks that would eventually become planets and moons. In the outer regions, where temperatures were low, ices could condense. This allowed objects to form with large amounts of volatile material. But not all of these objects grew large. Many remained small, never accumulating enough mass to become planets. They remained as they were, frozen, drifting, occasionally colliding. Over billions of years, gravitational interactions, especially with Neptune, scattered some of these objects, shaping the Kuiper belt into its current form. Some were pushed into more distant orbits, some were ejected entirely. Others remained in stable regions where they continue to orbit the Sun today. Pluto itself is part of this population. It is one of the largest Kuiper belt objects, and its moons, including Nix, are linked to that origin. Even though Nix formed later, after the giant impact that created Pluto's moon system, it still reflects the composition of the material that existed in that region. In this way, Nix acts as a bridge between a specific event, the collision that formed Pluto's moons, and a broader context, the primordial material of the Kuiper belt. By studying Nix, scientists can learn about both. They can examine how impact debris evolves into stable moons, and they can analyze the composition of that debris to understand what it reveals about the early solar system. This is especially important because direct study of Kuiper belt objects is rare. Most of what we know comes from distant observations, telescopes measuring light reflected from tiny, faint objects. Only one mission so far has provided close-up data, New Horizons, and even that mission had limited time. For Nix, only a few hours of detailed observation. Yet from that brief encounter, a connection becomes clear. Nix is not an isolated anomaly. It is part of a continuum, a range of bodies that share similar origins and materials. This connection helps answer larger questions. What were the building blocks of the solar system? How were they distributed? How did they change over time? Because the Kuiper belt is not just about distant objects, it is about the past. It preserves information that has been lost elsewhere. In the inner solar system, surfaces have been reshaped by volcanism, tectonics, and atmospheric processes. On Earth, the original record has been almost completely erased. But in the Kuiper belt, many objects remain relatively unchanged. Their surfaces carry signatures of ancient processes. Their compositions reflect the conditions under which they formed. Nix, though smaller and part of a secondary system, still carries those signatures. It has been exposed to radiation for billions of years. Its surface has been modified, but not completely transformed. It still holds clues. Clues about the materials present in the outer solar system. Clues about how those materials interact with radiation. Clues about how small bodies evolve over time. And because it is part of the Pluto system, it offers something more. A way to study these materials in a controlled environment. An environment shaped by a known event. The giant impact that created Pluto's moons provides a context, a starting point. From there, scientists can trace how material moved, combined, and evolved. This makes Nix especially valuable, not because it is unique in isolation, but because it connects multiple layers of information. The local, its role within the Pluto system, the regional, its relationship to the Kuiper belt, and the historical, its link to the early solar system. Together, these layers create a deeper understanding, a more complete picture. And they remind us of something important, that even the smallest objects can carry significant information, that even a moon only a few dozen kilometers across can reveal details about processes that shape the entire solar system. Nix is one of those objects, a small world orbiting a distant dwarf planet, but connected to something much larger, a vast region filled with ancient material, a region that continues to hold secrets. And as long as we continue to study it, Nix remains more than just a moon. It becomes a piece of a much bigger story, a story that began billions of years ago in a disk of gas and dust, and continues today in the cold darkness beyond Neptune. Nix is a moon, but it is also something older than that. It belongs to a family around Pluto, shaped by a violent collision long ago. Yet the material that makes up Nix did not begin there. It began in a much larger place, a vast, distant region known as the Kuiper belt. To understand Nix fully, you have to step back, far beyond Pluto, far beyond its orbit, and see the environment it comes from. Because Nix is not just part of a system, it is part of a population of objects that share a common origin, a common chemistry, and a common history. The Kuiper belt is often described as a ring, but that description is too simple. It is not a narrow band of material like the rings of Saturn. It is a wide, thick region extending across billions of kilometers, filled with objects of every size, tiny fragments, mid-sized icy bodies, and larger dwarf planets like Pluto. These objects are known as Kuiper belt objects, or KBOs, and Nix is connected to them, not directly in orbit, but through composition and origin. Most KBOs are made of similar materials: water ice, methane ice, nitrogen compounds, carbon-rich substances. These are the building blocks that existed in the outer solar system during its formation, cold enough to remain solid, stable enough to persist over billions of years. When scientists study Nix, they see hints of this same composition, a surface that reflects light more than expected, suggesting ice, a subtle reddish tint, indicating complex organic compounds, tholins, formed through radiation. These features are not unique to Nix. They are part of a pattern seen across many KBOs. Some objects are brighter, with cleaner ice. Others are darker, coated in radiation-processed material. Some show deep red coloration, others are more neutral. These variations reflect differences in history, differences in exposure, differences in composition. But the underlying materials are shared, and that is the connection. Nix is not an outsider. It is made from the same ingredients as the Kuiper belt objects around it. It may have formed through a specific event, the giant impact that created Pluto's moons, but the material involved came from that larger reservoir. This is why scientists sometimes describe the Kuiper belt in a very particular way, as the solar system's attic. An attic is a place where things are stored, not used every day, not constantly changed, but preserved. Objects placed there long ago remain, often untouched, accumulating dust but not being destroyed. The Kuiper belt is like that. It contains remnants, pieces of the early solar system that were never fully incorporated into planets, fragments that survived the chaotic formation period. While the inner solar system evolved, planets forming, surfaces reshaping, atmospheres developing, the Kuiper belt remained relatively stable, cold, quiet, distant. And because of that, it preserved information. Ancient material that has not been melted, reprocessed, or recycled in the same way as Earth's surface, or even the surfaces of other planets. When we look at Nix, we are looking at a piece of that attic, not directly placed there, but built from what was stored there. This makes it valuable, because studying Nix allows scientists to examine that preserved material in a different context, not as a free-floating object, but as part of a system where interactions have occurred, where debris has been reshaped, where surfaces have been altered, but not erased. This combination, preserved origin and dynamic history, is rare. It provides a unique opportunity to see how primordial material behaves when it is not left entirely alone, when it is influenced by gravity, impacts, and radiation within a system. The idea of ancient material is important here, because in the early solar system, conditions were very different. The sun was younger, the disk of gas and dust was still present. Planetesimals were forming and colliding. In the outer regions, ices condensed, volatile compounds froze, objects grew, but not all of them reached planetary size. Many remained small, and those small objects, those early fragments, are what populate the Kuiper belt today. They are not unchanged in every detail. Radiation has altered their surfaces, impacts have reshaped them, but their core composition still reflects the environment in which they formed. That is why they are considered primordial, not in the sense of being untouched, but in the sense of retaining original characteristics. Nix shares this connection. Its material likely comes from bodies that formed in that early disk, bodies that were part of the Kuiper belt population before the giant impact. When that impact occurred, it did not create new material from nothing. It redistributed existing material that already carried the signature of the outer solar system. This means that when we study Nix, we are not just learning about a moon, we are learning about the conditions of formation in the Kuiper belt. We are seeing how those materials behave when they are reassembled into a new structure, and we are observing how they evolve over time. The comparison with other KBOs reinforces this. Some KBOs are isolated. They drift through space, rarely interacting with other bodies. Their surfaces change slowly. Their histories are relatively simple. Others, like Pluto, have experienced major events, collisions, moon formation, gravitational interactions. Nix sits between these categories. It is not isolated, but it is not large enough to dominate its environment. It is influenced, shaped by the system it belongs to, and yet it still reflects the broader population. This makes it a link between isolated Kuiper belt objects and more complex systems, a way to compare how similar materials behave under different conditions. This is why the Kuiper belt is so important to planetary science. It is not just a distant region, it is a reference, a baseline, a place where we can study what the solar system was made of before planets fully formed. And Nix contributes to that understanding, even though it is small, even though it is far, even though it has been observed only briefly, because the information it carries is not just local, it is regional and historical. It connects the present to the past, the visible to the hidden, the known to the unknown. There is still much we do not understand. The exact composition of Nix's interior, the precise distribution of materials across its surface, how deeply radiation has altered its structure. These questions remain, and without new missions, they may remain unanswered for a long time. But even with what we know now, the connection is clear. Nix is part of something larger, a system within a system, a fragment within a population, a small piece of a vast ancient region. And that region, the Kuiper belt, is not just distant, it is fundamental. It holds the memory of how everything began. And in that memory, preserved in ice and rock, in color and composition, Nix has its place. A quiet world, carrying the story of a much older one. Nix is a small moon, but it belongs to something far larger than its orbit. It circles Pluto as part of a strange and delicate system. Yet the material that makes up Nix did not originate there. It comes from a deeper past, from a wider region, one that surrounds Pluto on all sides. That region is the Kuiper belt. To understand Nix, you have to understand that connection. Because Nix is not just a moon shaped by a single collision. It is made of the same ancient ingredients that fill the Kuiper belt itself. The Kuiper belt is often imagined as a quiet place, a distant band of frozen objects drifting slowly through space. But that image hides its true scale. It stretches across billions of kilometers beyond Neptune, forming a vast region filled with countless bodies, remnants from the earliest stages of the solar system. These objects are not uniform. Some are small, only a few kilometers across. Others, like Pluto, are large enough to be called dwarf planets. Between them lies an entire spectrum of sizes, shapes, and composition. But despite their differences, they share something fundamental. They formed from the same original material, a disk of gas, dust, and ice that surrounded the young sun billions of years ago. In the inner solar system, much of that material was transformed. Planets grew, surfaces melted and reshaped, atmospheres formed and evolved. The original record was altered, sometimes erased entirely. But in the outer regions, things were different. Temperatures were lower, solar energy was weaker, processes were slower. And because of that, much of the original material remained. Preserved, not unchanged, but less altered than anywhere closer to the sun. This is why scientists often describe the Kuiper belt as the solar system's attic. An attic is where old things are kept, objects that are no longer part of daily life, but not thrown away. They remain, sometimes forgotten, sometimes covered in dust, but still there, still carrying the past. The Kuiper belt functions in a similar way. It holds remnants of formation, fragments that never became planets, pieces that were not destroyed or reprocessed, material that still reflects the conditions of the early solar system. Nix is built from that material, even though it formed later after the giant impact that created Pluto's moons. The debris involved in that formation came from the same reservoir, the same population of icy bodies. the same chemical environment. This is what links Nix to other Kuiper belt objects, not through direct interaction, but through shared origin. When scientists compare Nix to other KBOs, they look for patterns, surface brightness, color variations, spectral signatures. Nix appears brighter than many distant objects. This suggests a surface rich in water ice, material that reflects light more efficiently, but it is not completely uniform. There are subtle hints of color, a faint reddish tint in some regions. This points to the presence of complex organic compounds, substances formed when simple molecules are altered by radiation. These compounds, often called tholins, are common across the Kuiper belt. They form when methane, nitrogen, and other simple ices are exposed to ultraviolet light and cosmic radiation. Over time, these interactions create darker, more complex materials. They accumulate on surfaces, they change color, they create the reddish tones seen on many outer solar system objects. This is why some KBOs appear deep red, others more neutral, some brighter, others darker. Each one reflects a different balance between original composition and long-term exposure. Nix fits within this pattern. Its surface suggests ice that has not been completely covered or altered. At the same time, the presence of color indicates that radiation has had an effect. This combination makes it valuable because it preserves both the original material and the record of how that material changes over time. The idea of ancient material is central here. In planetary science, ancient does not mean untouched. It means preserved enough to retain information. The Kuiper belt contains such material. Ice that formed billions of years ago. Compounds that have existed since the earliest stages of the solar system. These materials have not been melted into oceans. They have not been recycled through tectonic activity. They have not been transformed by dense atmospheres. Instead, they have remained cold, stable, slowly altered at the surface, but largely intact at depth. Nix, though smaller and more dynamic than many KBOs, still carries this legacy. Its material is not new, it is ancient. It was once part of larger bodies that existed in the Kuiper belt before the Pluto system formed. When the giant impact occurred, that material was redistributed. Fragments were thrown into orbit. Some formed Charon, others formed smaller moons like Nix. In that process, the material was reshaped, but not replaced. This means that Nix is both a product of a specific event and a continuation of something much older, a link between the early solar system and the present. This connection becomes even more important when we consider how little we have explored the Kuiper belt directly. Most of what we know comes from telescopic observations, light reflected across billions of kilometers, small variations in brightness and color. Only one mission has provided close-up data, New Horizons, and even that mission only visited a small number of objects. Nix was observed briefly, for a few hours, from a passing spacecraft. Yet even in that limited time, the connection to the Kuiper belt became clear. The surface properties, the composition, the structure, all consistent with what we expect from objects formed in that region. But many details remain unknown. How thick is the ice layer? How deeply has radiation altered the surface? Are there variations beneath what we can see? These questions remain open because we have not returned, and the Kuiper belt remains largely unexplored. There is something profound in that, because while we have sent missions to Mars, Jupiter, Saturn, we have only just begun to explore the outermost regions of our own system. The attic is still mostly closed, still full of objects we have not seen, still holding information we have not yet uncovered. Nix is one of the few pieces we have been able to examine more closely, and even then, only briefly. But that brief look is enough to tell us something important, that the outer solar system is not empty. It is not uniform. It is not simple. It is filled with variation, with preserved material, with objects that carry the memory of formation. And those objects are connected, not by proximity alone, but by origin. When you look at Nix, you are not just seeing a small tumbling moon. You are seeing a fragment of something much larger, a piece of the Kuiper belt, a piece of the early solar system, a piece of a time when planets were still forming, when collisions were shaping everything, when the structure we see today did not yet exist. That history is still there, not in dramatic features, not in obvious ways, but in composition, in color, in the way light reflects from its surface, subtle signs, quiet evidence, preserved over billions of years. And that is what makes the Kuiper belt so important. Not because it is distant, but because it is old, because it holds what other regions have lost, because it allows us to look back, to see what the solar system was made of before it became what it is today. Nix is part of that story, a small world, barely visible from Earth, seen clearly only once, and yet connected to billions of other objects, all sharing the same origin, all carrying the same ancient memory. And in that connection, Nix becomes more than a moon. It becomes a reminder that even the smallest worlds can tell the largest stories. Nix is not a solved world. It is not understood in the way we understand the moon or Mars or even Pluto itself. It is something else, a place where every answer leads to another question, a place where one brief visit, one moment in time, was not enough. And so what remains are gaps, unanswered questions. The first question is the one that defines everything. Why does Nix tumble when most moons do not? We know what happens. We know that its rotation is chaotic, that it spins in a way that never repeats, that it does not lock into a stable orientation. But knowing what happens is not the same as knowing why, because there are other small moons in the solar system, irregular shapes, low gravity, similar sizes, and yet most of them eventually settle. They slow down, they align, they find stability. Nix does not. Is it only because of Charon, the shifting gravitational field, the three-body interactions? Or is there something else, something about its shape, its internal structure, its past? Because chaotic rotation is not just a condition, it is a balance, a state that must be maintained. And we do not yet fully understand what keeps Nix in that state, or how long it will last. Then there is the color, that subtle red region on its surface, a small detail, but one that changes everything. What exactly is it? We believe it may be tholins, complex organic molecules formed by radiation. We think it could be material transferred from Pluto or Charon. We suspect it tells us something about surface chemistry, but we do not know for certain. Is the red spot shallow, a thin layer on the surface, or does it go deeper? Is it uniform or concentrated in one region because of some past event? An impact, perhaps, or a localized deposit? Without detailed mapping, without close and repeated observation, the answer remains uncertain. And that uncertainty matters, because color is not just appearance, it is chemistry, and chemistry is history. Another question lies beneath the surface. Literally, what is inside Nix? Is it solid, a single coherent body of ice and rock? Or is it something else? A rubble pile, loosely held together fragments with empty spaces inside. Its density suggests something unusual, lower than expected, lower than many solid bodies. This could mean it contains a lot of ice, or that it is not fully compact, that it has voids, internal gaps. If that is true, then Nix is not just a moon, It is a collection, a structure formed from pieces that never fully fused. But we do not know, because we have never measured its interior. We have never seen beneath its surface. We only infer, estimate, model, and models can only go so far. There is also the question of its past. Could Nix have been larger? Was it once part of a bigger fragment that broke apart? Or did it form roughly at its current size? The giant impact that created the Pluto system was violent. Debris was scattered, fragments collided again, merged, separated. It is possible that Nix is a survivor, a piece that avoided further collisions. Or it could be a remnant. What remains after something larger was broken apart? There is no clear answer, only possibilities, and each possibility tells a different story. What happened in its early history, after the impact, after the debris disk formed? What path did Nix follow? Was its orbit always stable, or did it shift? Did it move inward or outward over time? Did it experience additional impacts? Surface features suggest collisions, but how many? How large? How recent? Without long-term observation, we cannot reconstruct that history in detail. We see the result, but not the process. And then there is the limitation that defines all of this. Time, not billions of years, but hours. The data we have from New Horizons comes from a single flyby, a single pass through the system. 9 hours of close observation, after 9 years of travel. 9 hours. That is all. From that brief window, we built our understanding. Images, measurements, snapshots of a world in motion. But snapshots are not enough. They capture moments, not changes, not evolution. We do not know how Nix behaves over long periods. We do not know how its rotation changes over time. We do not know if the red spot evolves, if frost accumulates or disappears, if impacts alter its surface. All of that requires time, repeated observation, and we do not have that. This leads to another question. What could a dedicated mission reveal? Imagine a spacecraft not passing by, but staying, orbiting the Pluto system, watching Nix over weeks, months, years, tracking its rotation, mapping its surface in detail, measuring its gravity field to understand its interior, scanning its composition with high precision, observing how light interacts with its surface over time. Such a mission could answer many of the questions we still have. It could reveal whether the red region is localized or widespread, whether the interior is solid or fragmented, how the chaotic rotation evolves, whether it is truly stable chaos or slowly changing. It could turn unknowns into knowledge, but such a mission is not simple. Pluto is far, very far. Reaching it takes years. Designing a mission takes time, resources, commitment, and so far there is no confirmed return, which means that for now, Nix remains distant, observed once, understood partially. There is a kind of frustration in that, a quiet one, not dramatic, but persistent, because we know what is possible, we know what could be learned, and yet we are limited by distance, by technology, by time. We had one chance, one moment, and we used it. But it was not enough. It could never be enough, because worlds like Nix are not simple. They cannot be fully understood in a single encounter. They require patience, observation, return. And until that happens, questions remain. Why does it tumble? What is beneath its surface? Where does its color come from? What happened in its past? What is it made of in detail? How will it evolve? These are not small questions, they are fundamental. They define what Nix is, and yet they remain unanswered. Not because they cannot be answered, but because we have not yet gone back. And so Nix continues, orbiting, tumbling, changing while we watch from a distance. with data that is limited, with knowledge that is incomplete, and with a growing understanding that even in our own solar system, there are still worlds we have barely begun to know. Nix is small, easy to overlook, easy to ignore. A distant moon orbiting a distant dwarf planet, lost in the outer darkness beyond Neptune. And yet, it may be one of the most important moons we have ever seen, not because of its size, not because of its brightness, but because of what it teaches us. Nix shows us something that should not happen, or at least something we did not expect. A moon that refuses to settle. A world that does not follow the simple rule that governs most moons: stability. In the solar system, time usually removes chaos. Rotation slows, motion stabilizes, patterns emerge. But Nix resists that. It continues to tumble, not temporarily, not as a short-lived phase, but as a long-term state. And that changes how we think about small bodies, because it proves something important. Stability is not guaranteed, even over billions of years, even in a system that appears ordered from the outside. This forces us to rethink assumptions, to reconsider how rotation evolves, to understand that under certain conditions, like those created by the interaction between Pluto and Charon, chaos can persist, not as a failure of the system, but as part of it. Nix also matters because it is not alone. It exists within one of the most unusual systems in the solar system, a system where Pluto and Charon orbit each other like a binary pair, where multiple small moons move in resonance, where orbits are structured, but rotations are not. This system is a natural laboratory, a place where gravitational interactions are more complex than usual, a place where we can observe how multiple bodies influence each other over time. And Nix is one of the clearest examples of how those interactions can lead to unexpected outcomes. It shows us what happens when a moon is caught in a shifting gravitational environment, when the forces acting on it are never quite constant, when equilibrium is always just out of reach. But the importance of Nix goes even deeper, because it connects us to the past. The material that forms Nix is ancient. It comes from a time when the solar system was still forming, a time of collisions, of debris, of transformation. The giant impact that created Pluto's moon system reshaped everything. It took existing material from the outer solar system, and rearranged it, formed new bodies, created a system that still exists today. By studying Nix, we are not just looking at a moon, we are looking at a fragment of that history, a piece of the early solar system preserved in ice and rock, a record of processes that shaped not just Pluto, but many other systems as well. Because similar collisions likely occurred elsewhere, on larger scales, closer to the Sun. Even Earth's own moon may have formed in a similar way. Nix helps us understand that pattern. That formation is not always gentle. That destruction can lead to creation. That systems can emerge from chaos. There is also a broader lesson, one that extends beyond Pluto, beyond the Kuiper belt, beyond any single object. It is the lesson of complexity. We often think of the solar system as something orderly, planets orbiting the sun, moons orbiting planets, everything moving in predictable paths. And on a large scale, that is true. But when we look closer, at smaller bodies, at specific systems, we see something else. We see variation, irregularity, chaos. Nix is part of that. It reminds us that not everything follows the same rules, that even in a system governed by gravity, one of the most predictable forces we know, unexpected behavior can emerge, and that behavior can persist. This is why small moons matter, because they are not as constrained as larger bodies. They are more sensitive, more responsive to subtle forces, They reveal details that larger planets might hide. They preserve conditions that would be erased elsewhere. And they surprise us again and again. Nix is one of those surprises. A moon that should have stabilized, but did not. A world that should have become predictable, but remains chaotic. A place that forces us to ask new questions and to accept that we do not yet have all the answers. There is also something else, something less scientific, but no less important, a kind of quiet beauty. Because Nix is not dramatic. It has no storms like Jupiter, no rings like Saturn, no thick atmosphere, no oceans, no volcanoes. It is small, cold, dark, and almost completely unnoticed. Nobody stands on its surface. Nobody watches. No spacecraft remains there. It was visited once, briefly, and then left behind. And yet it continues, tumbling, spinning in a way that never repeats, moving through space without pause, without pattern, without witness. There is something poetic in that. A world that does not follow expectations, that exists outside of what we normally consider stable or ordered, a place where motion is constant and understanding is incomplete. And perhaps that is why Nix matters most, not because we fully understand it, but because we don't, because it represents the limits of our knowledge, the places where observation ends and questions begin. It reminds us that even in our own solar system, something we often think we know well, there are still mysteries, still unknowns, still worlds that challenge our understanding. So tonight, as you drift towards sleep, imagine that distant system, far beyond Neptune, far beyond the reach of warmth and light. Imagine Pluto and Charon locked in their endless orbit, and beyond them, a small irregular moon, Nix, turning, shifting, tumbling through space. No pattern, no pause, no observer, just motion, endless, silent, free. And while we remain here, trying to understand it, it continues, unchanged, unwatched. A reminder that the universe does not need to be seen to exist. And somewhere out there, in the cold darkness beyond Neptune, Nix is still tumbling, completely alone, completely free.